Friends, this is a conclusion for the whatever theory we learned in previous videos. So here is a flowchart of dead laptop motherboard. That means if your motherboard is not powering on, then you have to follow the simple steps. And what is there in the flowchart? Flowchart means there is a simple questions like this. Laptop is not powering on. Here is the question. The question number is check 18 volt or 19 volt is coming at the current sensing resistor. Now this is a question. If it's coming, then you have to go down. If not coming, then you have to go this side. Okay. So this is a simple task or simple flow you have to follow to diagnose problem. Where is the exactly problem, to locate the problem where it is. So this is the best methods in which you will learn or you will find exact problem in the motherboard. So let's start. So here are these are the questions. I already told you these are the questions, and the answer of the question is either yes or no. So if it is the answer is no, then you have to go here. If the answer is yes, then you have to go down. Same the another question. If the answer is no, then you have to go that's this side. If answer is yes, then you go down. It's like that. So the first question is check the 18 volt at the current sensing resistor. 18 volt at the current sensing resistor. Where is the 18 volt is there? 18 volt is there. That is the current sensing resistor. That means it is on the battery charging section, the A section, which is there are two MOSFET and this adapter voltage cross this two MOSFET and come across this resistor. So there is a adapter voltage should be there. Now if the voltage is coming, then you have to go down, and if it's not coming, then you have to go this side. What is this side? This side is you have to check the volt in. V means the volt in section, that is the A section. That is the adapter input and battery charging section. There you have to check either these two MOSFETs may be open, or there is a adapter input and battery charging chip is not functioning properly or not triggering those MOSFETs, or the adapter voltage is not coming properly, something like that. So you have to check that. Okay. And the next, if the 18 volt is coming across the current sensing resistor, then you have to go down and you have to check the 3 volt is coming on the SIO VCC pin, or if it is a EC bias is there, then you have to check at the EC bias pin number 8, and sometime in V standby pin and the SIO pin. For that you have to open a schematic diagram, go to the SIO page and check there 3 volt is coming at the SIO V standby pin or the VCC pin. Now if the 3 volt is not coming at the SIO V standby pin or VCC pin, then you have to go this side. That means the problem in the B section, that is the 3 volt and 5 volt section. The 3 volt and 5 volt section, which is responsible to generate the 3.3 volt and 5 volt. There is a linear regulators are there and the buck converters also there, but initially start the linear regulator, and if that voltage is not coming, then something wrong in this section. So either in that case the chip is faulty, or chip is not getting input voltage or not generating output voltage. So you have to check that. Okay. So now the next question is, if the voltage is coming on the SIO, then you have to go down and you have to check the 3 volt at the power button or the power switch. So wherever the power button on the motherboard, at that point you should get a 3 volt, and when you press that power button, it will become a 0, and when you release back, that means when you press the power button at that time, that 3 volt will become a 0, and when you release that power button, then it's come back to 3. So that variation should become there at that power pin. So this signal you can check on the power button, or you can check on the SIO also, because the same signal is going to the SIO input. Okay. So if this variation is not coming, then in that case the power switch is bad, the power button is bad, or that flexible cable is bad which is connected to the a motherboard, so that could be the faulty. Okay, so now the next question is, if this 303 variation is there, then what you have to do is you have to check the next signal is called the RSM-RST. RSM-RST stand for resume and reset, and after pressing a power button you should get a 3 volt there, and this signal is generated by the SIO. Okay, and the another signal simultaneously you can check, there is a PM power button. PM, that is a post power button, or it's sometimes it's called a DNB power on, or it's called the PBTN. So either of any of the one of the name will be there. This is the output switch that is going SIO to PCH or the SIO to CPU, and there you will, once you press that input power button at that time, there will be 3 volt become a 0 and come back to 3. That means there 303 variation will be there. So you have to check that. Now if this variation is there, then you have to go down, and if this variation is not coming and the RSM RST is also not coming, then you have to go right side. Then the first thing that you have to check, that is the EC reset. EC reset, at that pin you should get a 3 volt, and if the 3 volt is not coming there, then in that case you have to check why this 3 volt is not coming. You have to check RTC clock 32.7 kilohertz, then you have to check thermal trip signal, that will be the 3 volt, then AC in signal, that is also 3 volt, and lead sensor switch, lead sensor, that is also a 3 volt. So all this pin you should get a 3 volt. Okay, all this pin, how much voltage you will get? A 3 volt. Okay, and if all the 3 volts are coming but nothing is happen when you press the power button, but not SI is not responding, RSM RST is not generating, PM power button is not generating, and in that case what you have to do, you have to flash the EC bias. There are two bias, main bias and EC bias. In that case, if your laptop is not powering on, in that case you have to flash the EC bias. EC bias may be faulty, so you have to go to the online and find the EC bias. We normally use from Winafix or other sites. There are so many Telegram groups also, they provide the bias, and the EC bias size could be 128 KB or 256 KB. So you have to download, and most of the newer models are the EC bias is merged into the SIO. So in that case you need a SIO programmer. So normally we use here a ENIT programmer, so to program the SIO. So flash the SIO, but the flashing the SIO, actually we are doing the flashing the EC bias only. Okay, so you have to flash the EC bias and again give the power to the motherboard, and you have to check again. If the problem solved, then it's okay, but still flashing the bias also doesn't affect, flashing the bias also doesn't work the laptop. In that case your SIO may be faulty. So in that case what you have to do is you have to replace the SIO. SIO is bad. Okay, so in this way you can solve the problem like this. So now if now this RSM RST is coming after the power button press, and then PM power button also is coming, but still laptop is not powering on, in that case what you have to do is you have to check this two signal which is coming from PCH or from CPU. So the name of the signal is SLP S3 and SLP S4. It's something called PM underscore SLP S3 and SLP S4. So these two signals generated by the PCH and given to the SIO, and this both the signal should be a 3 volt after pressing the power button. Now if this 3 volt is not generated by the PCH, then what you have to do is you have to go right side, and first you have to check VCC DSW signal. VCC DSW signal is a VCC stand for the supply power, and DSW means the deep sleep wake up signal. This signal is generated by the 3 volt and 5 volt sections, and this 3 volt is given to the PCH or the CPU. So this voltage you can't check directly on the PCH or the CPU, but you can check this signal on the 3 volt and 5 volt section at the output of the buck converter at that coil. So if this 3 volt is coming there, that means obviously this 3 volt is reaching to the PCH. If the 3 volt is not coming there at the 3 volt and 5 volt section, then there is something wrong. There's a problem in the 3 volt and 5 volt sections. Then in that case, you have to diagnose the problem why this 3 volt and 5 volt sections not working. Okay, so this is a VCC DSW. So you have to check like that. Now if the VCC DSW is coming but still laptop is not powering on, the next signal that you have to check, that is RTC reset, RTC RST and the RTC VCC. That signal you have to check. This signal also a 3 volt, and if the RTC clock is a 32.7 kilohertz, this signal you can check without turning on the laptop. Just give the power and you have to check this signal. RTC reset should be a 3 volt, and if this 3 volt is not coming, then you have to check why this signal and voltage is not coming. Now RTC reset is also coming but still laptop is not powering on, then you have to go down and you have to check this signal. It's called DPWROK. The DPWROK is a signal generated by the SIO and given to the PCH. What is the mean of this signal? The mean of this signal is deep sleep power OK signal, means SIO informing to the PCH that you be ready, now you already got the 3 volt and you wake up from your sleep state. That is the meaning of the signal. So this in short form it's called a DPWROK, that is deep sleep power OK signal, and that signal should be a 3 volt, and if it is coming a 0 volt, then your laptop won't turn on. So if it is coming a 3 volt, then you have to check why this DPWROK is not coming properly. Okay, so after that, if the DPWROK is still coming but still a laptop is not powering on, in that case what you can do is you can heat the motherboard. So now what do you mean by heat and how to heat the motherboard? So heating is a 2-3 method. Either you can heat the motherboard by BGA machine, you can put the motherboard on the BGA machine and start your temperature profile, let go the temperature to the 220 to 240 degrees Celsius and let it cool down and recheck the motherboard. Or if you don't have a BGA machine, then you can check by using a hot air gun. Use a 300 degree temperatures and just blow the PCH or the CPU on the just blow the PCH and the CPU with the hot gun at the 300 degree for 2 to 3 minutes. Okay, now, or if you can use a OTG oven also for that purpose, at that time you can use OTG oven, put your motherboard into the oven, remove a CMOS battery, RAM and CPU, put it motherboard into the oven at 150 degree for 15 to 20 minutes. Okay, and just recheck after heating. If the problem is solved, then okay, but if still problem is not solved after hitting the motherboard, in that case the PCH could be faulty, or if the new generations are laptop, then the CPU is a faulty. So you have to check that. Okay, so it's called this is the ultimate steps. After, now we'll go back and we'll check. Now if the SLPS3 and SLPS4 also coming but still laptop is not powering on, then what you have to check? You have to check this signal is called SUSP, CSON or VRON. These three signals generated by the SIO and sent to the different buck converter. Now if these signals are not generating, in that case SIO is bad, so you have to replace SIO. Okay, now the next is, if these three signals are coming, or one or two signals are coming but still laptop is not powering on, then you have to go to the related PWM chips. PWM chips means the buck converter. In motherboard there are so many buck converters, like for 3.3, 5, 1.5, 1.8, 1.05, graphics core, CPU core, VGA core. There are so many buck converters are there which generate a different voltages for different chips. So in that case, this buck converter is not working, so that the motherboard is not going to turn on. So friend, in this way you are to follow this sequence, and I am 100% sure that you can able to rectify the problem in the motherboard. Okay, so now we'll go to the next page, where how we identify the if the SIO is bad. Okay, so here I given a numbers, simple numbers I given here. So if you want to conclude whether my SIO is working or not, for that these are the signal, these are the step signal you have to check one after another. So what are these signal is? First, SIO need a power, SIO need a power, and that's supposed to be a 3 volt, and that signal you can check on a V standby pin. The newer SIOs work on a 1.8 volt also. So okay, so you have to check this. After that, 3 volt, the next signal is you have to check, that is the EC reset. EC reset, that is also 3 volt, which is reset by the RC circuit. The next signal that you have to check, AC in or the AC OK, that is also 3 volt. Another signal is the lead switch or the lead sensor, that is also 3 volt. And the last signal is called the thermal trip signal, that is also 3 volts. So all this from 1 to 5, all the signal should be on a 3 volts. So you have to check one after another. And if one of the voltages is 0, then you have to find why this signal is coming as 0 volt. Okay, so you have to check that. And after that, if all these 5 signals are proper, then you have to verify this bias, EC bias. Okay, if the bias is on external side, that means the bias is outside on the SIO, then in that case you have to flash the bias, check all the connectivity between the SIO and the bias. And if the bias is internal, is the part of the SIO, in that case you have to flash the EC bias. Okay, so these are the 6 steps you have to check. Now if all the things are perfect, like from 1 to 6 all things are confirmed, you are okay, and when you press the power button, that is a step number 7, but the output is not coming, step number 8 and 9 are not coming out, then in that case the SIO is bad. We'll repeat again. See, if all the signals, step number 1, step number 2, step number 3, step number 4, step number 5, step number 6, everything is perfect, all the input criteria which is required to work SIO, that's all they are getting, the bias is also okay, and after this pressing this power button, NBS on, output is not coming out, that is RSM, RST and PM power button, in that case the SIO is bad. So in that case you have to replace the another SIO. Okay, the next will go, how will come to know that CPU is bad or the PCH is bad. So here also the same thing, the PCH or the CPU generate the SLP3 and SLP4 signal. SLP3, SLP4 signal generated by the CPU or the PCH after he receive the information from the SIO that the power button is pressed. In that case, suppose your SLP3 and SLPS4 signal is not coming out after pressing the power button, and the power button signal and RSM RST is coming, in that case what you have to do is you have to check all the signals. You have to first check RTC VCC, you have to check RTC reset, then VCC DSW, DPW are okay, SLP SUS. So all the signals are 3 volt, 3 volt, 3 volt, 3 volt, 3 volt. This 4, 5 signal you have to check 3, 3, 3, 3 volt. Okay, and you should get out this signal that is called SLP SUS. Then RSM RST, that is 3 volt. Then the power button, there will be 303 variation will be there, and that signal also you can check on the multimeter on the SIO. Now if all the signals are going to the CPU or the PCH, all signals are perfectly all right, but the CPU is not generating this SLP4 and SLP3, then in that case the CPU is a bad. In that case the CPU has to replace. So same thing here happened to the PCH also. From generation 1 to generation 3 normally the PCH is used, and fourth generation onward the PCH is not used, only there will be CPU, it's called the SoC. That means the PCH is merged into the CPU. So dear friends, in this way you are to follow these signals steps one after another, and you will 100% rectify the problem in the motherboard. So firstly you have to follow this flow chart, and these are the two important pages are there: how to identify the SIO and how to identify the PCH. Okay, so I hope you understand this video perfectly. Thank you very much.